13. Okay, so everyone has these two important facts down. Wait. I have one for you. Okay, so the first problem has 3 examples, and it's just simplifying radicals. So we've been simplifying radicals for what, 2 weeks, 3 weeks? A long time. So you are going to simplify the radical just like you always do, and then if there's a negative inside the radical, you'll put an I with the answer. Okay, so you can think of this, if you want to show a lot of work, you can split this up into the square root of 169 and the square root of negative 1. Is it 169 times negative 1, negative 169?
Yes.
Okay. And then you just simplify. What is the square root of 169?
13.
13. And then every time you have the square root of negative 1, it is.
That's what you do. Last year it seemed harder in the way they explained everything.
Okay.
Maybe she's just a better teacher. I'm gonna go with that.
I'm totally recording this, but okay.
Miss
So
Hendricks.
radical negative 5. So let's split that up into 5 times negative 1. Can you simplify radical 5?
Nope.
No.
So leave it, radical 5. What's the square root of negative 1, Josh? I. Okay, now it's a little tricky when there's still a radical to answer. You don't want to put the I right here because it looks like it's underneath the radical, so just move the I to the front. If you put it in back, you have to make sure it's very clear that it's not in the radical, it's outside. Now there's one thing I didn't do. You notice something I forgot? Yeah, the negative in front, just means the whole answer's negative.
So,
That's just I is not negative. I is I. I is just like X. It's just a variable.
what it represents.
It represents the square root of negative, which we did.
Which doesn't exist.
So you're trying to make this too difficult. That's it. You're done. Stop.
I like those.
Why is the I on the outside of the radical? Will it always be on the outside of the radical?
Yes.
Okay.
That's what we're doing, is taking this negative out and replacing it with an I. But it goes on the outside. Okay, so radical negative 48. So radical 48 at negative 1. And you don't have to do this every time. I'm just showing you where it comes from. So obviously the answer is going to have an I, but what about 48? Radical 48. How do you simplify that?
4 radical. 2 radical.
4 radical. Keep guessing.
Radical A.
What? Yeah. 16 and 3. It's like that. Did you say that? Oh, I'm sorry. I thought you were saying 4 times 3. Okay. I apologize. You were right. So radical 16 is 4. And radical 3, where does the I go?
After 4. Negative. Right? Nope. No. I must have just gotten a ton smarter.
The only time you have a negative is if you have a negative with the problem.
Oh, okay. Let's do quantum theory next.
Okay, I don't.
Why does this just seem so much easier this year than
You're
it
just
was?
so much smarter. Your brain has had a whole 12 months to develop.
It seems so much easier, but I get my brain.
Your brain does not. Well, maybe after the big test. We only had one big test, and it was a hard one.
Yeah.
This one should be a lot better. Okay, so now let's do a couple of problems, multiplication and division. Okay, first thing you gotta do is take out that negative. So make it, take out the negative and make it up. Okay, 7 times 15?
Oh, so we just
No, you just multiply.
with 105.
And then would that be I squared?
And then I times I is
I squared.
I squared.
Negative 1.
Right, so hold on. See, you know more than you need to know already. Square root of 105, can I simplify that? Not more than you need to know, just faster than I.
Yeah.
Can?
You get 1.
Can you simplify radical 105?
Oh.
But, okay, now, getting to it. What is I squared?
-1.
So the answer is...
-1.
Negative radical.
You can write -1 radical 105 or just negative
Oh,
radical.
okay, I'm sorry.
She's not going to use it.
Sure I am. I don't care.
Have
It's
fun
just,
taking
it's just for people who aren't here, so they'll have a great time.
He's not here right now.
Ellie.
Have fun taking these notes, Ellie. And Dulce.
There's some kids that come to their
Oh,
And Thomas.
and people in other classes.
And people I don't know.
Okay. So the next problem, take out an I, make it positive. Take out an I, make it positive. And then, now we're dividing. So what happens when you have I over I? It's like X over X. Think of I as like an X. It's just a variable that represents something. Now, there's two ways to do this. You could start simplifying these radicals. That's the hard way. The easy way is divide first. What's radical 300 divided by a radical 100? Radical 3. And then simplify that if you can. But I'm pretty sure that's all you can do. Okay, question so far. Still smart. Imaginative? Okay.
That's a word.
Yes, I think. Okay, 3 plus 2i plus -4 plus 5. This is where some people get confused, but if you think of this as a different kind of problem, you've already done this. You know how to do this. All we're doing is adding like terms. It's just like, if this said 3 plus 2x plus -4 plus 5x, everybody in here could do that. And that's all you're doing. It's the exact same thing. So if I say add like terms, what needs to go together?
3 and 4 is 2.
Yeah, 3 and -4 is? I knew what it meant. 2i and 5i? Done. Okay? As long as you don't have the square root of -1 anywhere, is there a square root of -1 in this problem?
Nope.
Is there an I squared in this problem?
Nope.
No.
Then we're done.
So you only have an I squared, like if you're distributing, multiplying.
Can I go to the next problem?
Yes.
Okay. Still adding like terms, except for subtraction. So if it's subtraction, what could you change? Yeah, you could change it to addition. And if you change this to addition, what does that do to the parentheses?
It makes those positive.
We're just distributing that negative, and it makes it 3 plus 2i. So now, add like terms. 4 plus 3 is 7. I plus 2i. It's just like 1i plus 2i.
3i.
Questions?
That's 12.
Next. I'm going fast. Tell me if I need to slow down. I will.
What was the answer to the last one?
7 plus 3i.
7 plus 3i. Okay, what am I doing in this problem?
Multiply.
Multiplying. So multiply. 3 times 27 is 81. What is I times I? I squared.
So
Okay, so in the problem, if you have a radical -1 or an I squared, you're not done. I have an I squared. So I need to replace that. I'm going to show you the long way, but most of you are going to get this easily and you can just write the answer. The long way is to replace that with a -1. That becomes 81 times -1, which is
-81.
-81.
Okay.
So the shortcut is if you see an I squared, what's that going to do to your sign? Right. So if you see, you don't have to write this down. Just do a couple of them. So 16i squared is what? -16. -16.
Okay, so what if you had like, yeah.
So -8i squared would be
8.
I knew what you were thinking. Got it?
Yep.
It's getting a little bit harder, but not too bad.
Try the factory.
I agree. And the long division. I can think of, maybe we should make a list. Anytime something seems difficult, make a list of everything we've done that's harder than factoring's at the top. Rational expressions. Adding fractions. Graphing?
I
graphing.
Oh.
Great. What do I do? Distribute. So 5i times negative 6. And 5i times 2i is plus 10i squared, and then I already heard you say that's the same thing as what? Yeah, so if you see an I squared, it just changes the sign. It's negative 10. But make sure you take the I off. It's not negative 10i or negative 10i squared. It's just negative. Can I do anything else?
No.
No like terms, so I'm done. Okay. You can leave your answer like this, that's fine. Sometimes it'll say, like especially a test might say write the answer in standard form. And I didn't go over this because this is where people get confused at the beginning. If I show you this first, I'm like, here's what a complex number is, this is the real part, this is the imaginary, people are saying. But it's really not that hard. If it said write it in standard form, all you would need to do is make sure the number that doesn't have an I comes first. The number that does have an I comes first. Okay. Next. Now we're getting to fun ones. Well, yeah, is this addition?
Foil.
Okay. It's multiplication, so we're going to just let you guys teach. First, 4 times 1.
4.
Outside.
Negative 8i.
Inside.
3i.
And last.
Negative 6i squared.
Siri.
Sounds like a constraint. Okay. Since I have an I squared, replace the I squared with negative 1. What does it become?
6.
Yeah, so it's like, just mark that out and change the sign. So plus 6.
I have the answer.
Now add like terms. 4 plus 6 is 10. Negative I, 8i plus 3i is
5i.
This is a lot easier than foiling when we had radicals. When you foil and you have I in the problem, your answer will always simplify down to a binomial, 2 terms. One without an I, one with. Yeah,
Standard
that's
form.
good.
This is switching.
I'm thinking, I don't understand why it's so much easier this year.
Maybe it's because like,
We had a rush.
That's right.
So much stuff done.
You understood this last year, didn't you?
No. I
4 plus 9. Okay, we're almost done. And you can tell me all about your difficulties last year. 4 plus 9i and 4 minus 9i.
You can do that thing that you said.
You can foil or
you can take the shortcut.
these are conjugates. What does that mean?
They're the obvious one.
All you have to do, the outside and inside will cancel each other out. So all you have to do is just first. So 4 times 4 is 16. 9i times negative 9i. Negative 81 I squared. Simplify.
97.
Plus 81, which is?
97.
When you foil conjugates, your answer will always be just a number. No I at all. Got it? Okay. You got 3 more problems. The next 2 are the hardest. Give me a fair warning. People are going to break out in song next year. Okay, this is division, but just like with radicals, you can't really divide that. I mean, you could divide all those by 2 if you wanted, but it still would be dividing the whole thing. instead, we're going to rationalize the denominator. You remember what that meant when we did radicals? What did rationalize mean?
Get rid of the radical.
Yeah, get the radical out of the denominator. So when you rationalize with complex numbers, your answer will be written so that there's no I in the denominator.
So,
Then you can. That's easy. So the way you're going to do that, this is just like radicals. You're going to multiply by the conjugate, the opposite of conjugate. So the opposite of 2 plus 2i is 2 plus 2 minus 2.
So cancel. Or
Hold on. Okay, on the top, distribute. 16i minus 16i squared or
16.
16i plus 6. Over. Okay. Denominator, what do I need to do?
Foil first.
Foil, but just do the first and last. Because they're conjugates. 2 times 2 is 4. 2i times negative 2i.
4.
Okay. Negative 4i squared, which is, so, is there an I in the denominator?
Nope.
No, so we were successful in rationalizing. So that is the answer, but you can simplify it a little bit more.
Mm-hmm.
What can you do?
16. 16i. I'm sorry.
2 by 2 plus 2.
You can divide plus 2.
How about just divide everything by 8? Just simplifying a fraction. Reducing. Questions? Are you confused?
Nope.
2 more.
Hardest question.
This is the hardest. 2 plus 2i. Can we go back? I wasn't talking about
She said 2.
If I said, are you confused? No, they're not. They're fine.
Yeah.
You're going to answer for the whole
I
class.
knew what she was going to say.
In charge. Okay, we're doing the same thing, rationalizing. What do we need to multiply this denominator by?
3 minus 2i.
3 minus 2. Okay, this is the hardest one because what do I have to do in the numerator, the top?
Foil.
Like a foil. So it's not really this difficult, it's just does that. So in foil the top, you get negative 21 plus 14i plus 12i minus 8i squared,
Yep.
which is
Apes.
if you don't want to even write that down, if you want to go and write plus 8, that's fine. That's good. Shows you know what you're doing. At like terms. So negative 21 plus 8. Okay. Negative 13. And 14i plus 12i is 26i.
Oh.
I didn't leave a lot of space. Oh well. Denominator, foil, but it's conjugate, so first and last. So 9 minus 4i squared, which is really 9 plus 4.
That was not hard.
Is that too fast?
And then you can simplify.
These are nicer than radicals because they always simplify really well. Radicals sometimes you end up with crazy answers.
Negative 1 plus 2i.
Okay, divide everything by 15. Great job.
I like this.
Good. I'm glad you it was good anyway.
I know.
Okay, one more. Wait, more problems.
That looks weird.
One.
Oh, this is right here. You need to start it.
Yeah, but let me show you how because it's really not that hard. You need to understand where it comes from. write down, just leave a little space underneath. There's really not a whole lot to do. You're going to have to show your work on these, so if you're just using your calculator, you better be paying attention. Especially on the test, I'm not going to take just answers.
What?
Yeah.
Test.
It means you don't know what you're doing. If all you're doing is typing this in calculator, you don't have a clue what you're doing.
Well,
And
that's
you
all
don't
I think
understand.
I'm doing.
Not true. Okay,
Yes.
when you look at these, there are 4 possible answers. The answers are either going to be 1, -1, I, 1I, or negative I, or negative I. And that's it. The way you figure this out, go back to our important, 2 important rules. We're going to use the second one, that I squared is -1. Well, if I squared is -1, I to the 16th is just a bunch of I squared, a bunch of I's. So you need to count up how many there are. So we split them up into pairs. If I have 16 I's, how many pairs is that? Or how many I squared is that?
Oh, 8. I'm sorry.
8. Okay, does that make sense? Just say there's 8 pairs of 2. Well, I squared we know is -1. So now I have 8 -1s. So you should be able to do this without a calculator at all. You probably, hopefully, learned this back somewhere in your life. If you have a negative number to an even exponent, what's the answer? Is it positive or negative?
Positive.
Positive. So the answer is just. So it's an even number of negatives. An even number of negatives that cancel each other out. Okay, so these are all the same thing. I just want to give you. I'm going to give you an example of one of each answer. So I to the 38. How many pairs?
19.
Thank you. So that means that's -1. Or 19 pairs of -1. Now we have an odd exponent. So the answer is
Negative.
-1. Even exponent is positive, odd exponent is negative. Does that make sense? Okay. No comment. Great. So if I want to figure out how many pairs of i's are in 43, well, you can't, if you did 43 divided by 2, you get a decimal. We'll go down by 1, 42. How many pairs of i's are in 42? 21. But that's just 42, so I need another one.
Oh,
So it's like 42 plus another I.
so it's negative
That one.
1.
Hold on.
I'm sorry.
Okay, 42 plus 1 is 43. So, so -1 to an odd exponent, is that negative or positive? Negative, but then I've had an I. Does that make sense? So there's a leftover I. So I know you can guess what the next answer is going to be, but I'll show you why. So you do the same thing. It's 21. Well, that's odd. So go down to 20. How many pairs are in 20? 10. That's 20. 2 times 10. And then you need another one to give you 21. So that is positive I. So really, you're just trying to figure out if it's positive and or negative, it doesn't have an I left. What do you think? You got this? Very good.
Bye. I'll